Alright, let's look at the differential equation problem number 20. Alright, so we want to find the implicit solution of the differential equation. Alright, so let's do that. Alright, so first thing I would do is I'm going to multiply both sides by the denominator. So we have 1 plus 2y plus 3y squared. Right, so we're going to multiply by those. Right, so we're going to have 1 plus 2y plus 3y squared. Right, so y prime, I'm going to write it as dy over dx because derivative is done with respect to x. And what's left on the right hand side would be negative 8. And if I want to, I don't like to have 1 minus x. I'm going to turn it into 1 x minus 1. You don't really have to do it, but here, so you have to still raise it to the 7th power. But this is a negative x minus 1, right? All right, then, what we want to do is we just want to integrate both sides. So we integrate both sides with respect to x. Right, integrate both sides with respect to x. Right, then we can cancel these. So, right, so you have negative 1 to the 7th power is negative 1. So we can actually cancel this negative sign with this negative sign there. Right, and then also we can get rid of this dx here and dx there. Right, so what you get here is going to be, right, antiderivative 1 with respect to y would be y, and the antiderivative 2y with respect to y would be y squared, and the antiderivative 3y squared with respect to y would be y cubed, right? That looks kind of nice, and this is equal to, right, 8 is just a number, right? Antiderivative x minus 1 quantity to the 7th power would be x minus 1, raise it to the add 1 to the power. It's basically the power rule, divided by 8. Right? Then you have some constant c. Right? So we can cancel 8 here and 8 there. Right? So this is going to be, simply we just have to clean it up. I kind of like to have y cubed first. So y cubed plus y squared plus y is going to be equal to quantity x minus 1 to the 8th power plus some constant c. Alright, so this is the solution of the given differential equation. And the reason why this is called implicit is that we're not writing as a y equals form, which is actually kind of hard to solve from here. So they allow you to kind of leave the solution as it is. So that's why it calls they call it implicit solution, right? But anyway, this is simply a separable equation. So all you have to do is I put all the y's on the left hand side and all the x's on the right hand side, then integrate both sides, then you're there. All right, that's it. I hope that this was clear.